Okay, welcome back to the electric circuit exam practice questions discussion. For the question number one, this is the circuit, motor and ampere, and here is the voltage source. Draw two clearly labeled arrows to show the directions of the electron flow and the directions of the conventional current in the circuit. So to draw the directions of the electron flow is from this one is the longer one is positive and the shorter one is the negative. So electron flow is from positive to negative. The directions of the conventional current, I mean. So this one is the conventional current. Conventional current, and the direction such like this, which is in the opposite directions of the conventional current, which is the movement of electron. So this is the electron flow. Okay, the next, the current in the motor is 13 ampere. The charge on an electron is 1.6. Calculate the number of electrons that pass through the motor every second. So the first we have to find the charge, which is Q is I is Q over T, so Q is I times time, which is equal to 13 ampere times time, which is every second, which means 1 second. So the result is with 13 coulomb. So if one coulomb, so if one electron is equal to 1.6 times 10 to the minus 19 coulomb, so how many electrons is 4? 13 coulomb. So number of electron is, so we cross it, this times this is 13 divided by 1.6 times 10 to the power of minus 19, which is equal to, if we use our calculator, the calculator say that 13 divided by 1.6, 19, is equal to 8.13 times 10 to the power of 19 electrons. Okay, next one. Define the electromotive force or EMF. EMF or electromotive force is the energy per unit of charge, because the EMF, which is the voltage, is equal to energy which is E, divided by Q, which is charge. The next one, the two lamps shown are identical. Each lamp has a potential difference of 3 volts across it and a current of 2 amps in it. PQ is a length of uniform metal wire. The resistance of PQ is R. Calculate the value of R. So what is R? R is at here. Yeah? So what is R? What is the resistance of PQ? So 2 amps at here, 2 amps at here. So there will be a current that blowing here, goes there, because from positive, yeah, goes here to negative. So this one is 4 ampere. Of course here is also 4 ampere, same, yeah, 4 ampere, because this is series, but this one is split, goes there and goes there. So here is 4 amps, and as we know that in parallel the voltage are the same, so this one is 3 volt, this one is also 3 volt, of course this one is 3 volt, and the rest is 6 volt. So we have 6 volt, this one is 3 volt, 12 minus 3 is 9, yeah. So this one is 9 volt, 9 volt battery. Now we are going to find the resistance. The resistance is equal to V divided by I, which is equal to 9 volt divided by 4 ampere, which is equal to 2.25 ohm. The next one, another piece of wire is made of the same metal as PQ. So the same metal means that the resistivity is the same, yeah? The length of the new piece of wire is twice. The diameter of new piece of wire is twice the diameter of PQ. Calculate the resistance of a new piece of wire. So this one is 2 times, yeah, the length of new piece of wire is twice. So there will be twice the length will be twice the resistance, right? And the diameter of the new piece of wire is twice the diameter, meaning that will be 1 over 4 the resistance. So the new resistance is now the old resistance is 2.25 ohm. So it means that 2 times 2.25 becomes 4.5, and then 1 over 4 of 4.5 will be 1.125 ohm. So the answer is 1.125 ohm. Next one shows sketch of the current voltage graph for an electrical component. Name the electrical component. Explain how you identify the component from the graph in figure 7.1. Name. So this is called a diode. Explanation. This only flow. So the current only flow in one direction. Current only flow in one direction. In one direction in a given voltage. Okay. So this is the explanation. Draw the circuit symbol for this component, or for the diode. We have like this, and then arrow, and like this. This is symbol for the diode. The next one, S1 is closed, S2 is open. The reading on the emitter is 3.9, and the source is 230 volt. Calculate the resistance of heater A. The resistance of the heater A. But this is the condition. S1 is closed, S2 is open. So this is closed, this is open. So we can find the resistance is equal to V divided by I, which is equal to 230 divided by resistance, which is 3.9, which is equal to 58 or 59 ohm. Okay, if you round up it, calculate the energy transfer by heater in 5 minutes. 5 minutes is equal to 30 seconds. So energy is vitamin, yeah. So voltage is 230 times current, which is 3.9. Is it 3.9 just now? Yeah, 3.9, and then times 300 seconds. So we will get the answer is 230 times 3.9 times 300, which is equal to 269,100 joules. S1 remains closed and S2 is closed. Determine the reading on the meter so you're working. So this one is closed, this one is closed. The wire is identical. Okay, so close. So what is the emitter reading? So we have to find the total resistance of two parallel resistance, which is R1 times R2 divided by R1 plus R2. We have 59 times 59 divided by 59 plus 59. We use our calculator. 3 is 3481 divided by 59 times 2, 1, sorry, which is equal to 1. Why like this? Okay, 1118, which is equal to 3481 divided by 118, which is equal to 30 ohms. So the current is voltage divided by resistance, which is through 230. Yeah, 230 divided by 30, which is equal to 7.67 ampere. Okay, the next one, the student set up the circuit shown in figure 7.1. Determine the value of the current measured by the emitter. So this, determine the value of the current measured by the emitter. So the total current, yeah, the circuit is like this. Okay, so the emitter will be the same with this. This is the total current, goes there, and then this join together in the same with this. So this is the in current, this is out. So according to the first law of Kirchhoff, say that the a number of current that into a node is equal to a number of current that out of that node. Okay, so if like this, it goes there. So I1, this is I2, this is I3. So I1 plus I2 is equal to I3. Okay, so of course the current will be 0.5 ampere. Calculate the potential difference across the 6 ohm resistor. Yeah, just times it, yeah, because the voltage is current times resistance. So current is 0.5, resistance is 6, 0.5 times 6, which is 3 volt. Show that potential difference across the 20 ohm resistor is 9 volt. Across 20 ohm, so this is identical. Wait, not identical actually. This is 3 volt. This is 3 volt. Of course, this one will be 9 volt, and this one will be 9 volt. And then we are going to find the yeah, 9 volt resistor will 9 volt will be, because 12 minus 3 will be 9 volt. Calculate the resistance of the resistor R. Yeah, of course, this is the current flowing here. I2 is equal to, we have to find I2 first. I2 is equal to 9, which is voltage, divided by 20, which is the resistance. So 9 divided by 20 is 0.45. Of course, I1 is equal to 0.05, because 0.5 minus 0.45, so 0.05. And then the question is the resistance. So the resistance is voltage over current, which is equal to, the voltage is back again, look, 39, yeah, 9 volt divided by the current, which is 0.05. So the resistance is 9 divided by 0.05, 180 ohm. It's the answer. The next one, figure 7.1 shows a circuit containing 6 volt battery of cells and 3 identical resistors. S1 is closed and S2 is open. The current in the emitter is 0.08 ampere. Calculate the resistance of R1. What is the resistance of R1 according to this question? Okay, so now there is no current that flowing here because this is open. So the one that current flowing is from R to R1, R2, and then back again because this one is closed. So we have to find the resistance of R1. Okay, so identical. This one is 6 volt. Of course, this will be 3 volt. This one will be 3 volt because 3 plus 3 is 6. This one is series. In series, the voltage is the sum of the source is the sum of the each voltage on each across the resistor. So what is the current? The current is 0.08. So of course, the resistance of R1 is voltage divided by current, which is equal to 3 divided by 0.08. We divided 3 divided by 0.08, 37.5 ohm. Next one, S1 and S2 are both closed. Determine the reading on the emitter. So we have to find the total resistance first. The total resistance is yeah, R1 and R2 first. We have to combine that. Yeah, R1 and R2 are the same. So R1 plus R2 is 37.5 plus 37.5, which is equal to 75 ohm. Okay, so this is parallel with this. Okay, so the total resistance will be 75. There are three identical, yeah, times 37.5 divided by 75 plus 37.5, which is equal to this one is 28125, 2812.5 divided by 75 plus 37.5, 112.5. So if we divide them, the result will be 25 ohm. So the total resistance is 25 ohm. Then we are going to find the total current. So the total current is the voltage divided by resistance. The voltage is 6 divided by 25. So the result will be 6 divided by 25 is 0.24 ampere. So this is the answer. Explain in terms of work done and potential difference why there is a larger heating effect in R3 than in R1, R3 than in R1, Yeah, why? Because R3, yeah, we can say that. What is the current in R3? This 0.24 at here. The total is 0.08, the emitter. Okay, the total current is 0.24. If because R3 is the smallest resistance, R1 and R2 is the biggest resistance because this is the sum. So the smaller the resistance, the higher the current that flowing through R3. So more electrons, we can say that more electrons flows, more electrons flows or flow through through R3, so that it can becomes heating. Yeah, make it heat. Okay, I think that's all for today. Next we are going to discuss for question number 6 until number 9. Okay, thank you, good night, bye.